Here's problem 38. The figure shows a cross-section of 3 parallel wires, each carrying a current of 20 amps. The currents in wires A and B are out of the paper, while that in C is into the paper. If the distance R is 5 millimeters, what is the magnitude of the force on a 2-meter length of wire A? So we have two wires, A and B, with currents coming out of the page, and then we have C with the current going into the page. Now the force per length between any two wires is going to be equal to mu naught I1 I2 over 2 pi d, where d is the distance between the wires. And in this case, all the currents are the same, all of our distances are the same, so the magnitude of all of our forces are going to be the same. Now as we look at wire A, there's going to be two forces on it. There's going to be an attractive force towards wire B, let's call it F1. And then there's going to be repulsive force from wire C, let's call it F2. The magnitude of these two forces will be equal. Hence, if we were to look at the x-axis here, our y components of these two forces are going to cancel out. So we're not going to have to worry about those. So our x components are going to add together. So we're going to end up with an F1x and an F2x adding together in a negative x direction like this. So that's what we're going to be interested in. Let's find the magnitude of these forces first. That's going to be equal to mu naught I times L over 2 pi d. So the force is going to be equal to mu naught 4 pi times 10 to the minus 7 times 20 amps times 20 amps, and we have a 2-meter length of wire, all over 2 pi times 5 millimeters. And that's equal to 0.032 newtons. Alright, so our residual then is going to be our net force is going to be equal to F1x plus F2x, and that's going to be equal to 2 times F cosine theta, where theta is this angle right here. In other words, for an equilateral triangle, all angles being equal, theta must be 60 degrees. So this is going to be equal to 2 times the force, 0.032, times the cosine of 60 degrees. Cosine of 60 degrees actually is 1/2. So we have 2 times 1/2, which is 1. So this is equal to 0.032 newtons. In the negative x direction as we're looking at it for wire number A. So as a vector, this net force would be equal to a negative 0.032 I newtons. And that would be magnitude and direction for this force. 0.032 newtons is our answer.